Hi everybody, I hope that you are doing well today. There are a couple of worksheets for you to pick up from the Flex Hall Supervisor. There's a half sheet, a full sheet, and then a blue note sheet. If you haven't gotten those materials yet, please go get those now. Pause this video and go get them. I'm going to have you start today by doing the warm-up. So you can see there's 4 questions for you to try. You are going to start by graphing a few points and then trying to find the midpoint. Go ahead and pause the video, and then once you have tried the problems, you can check your answers. Okay, so hopefully you've tried the problems on your own and you're ready to check your answers. So the first thing that we're going to do is to graph these 2 points. So here's 3, 0, and 11, 0. And then the next thing that we're going to do is to try to find the midpoint. There's a few different ways to do this. One way that you could do it is to try to work your way to the middle. So if I start with 3 and I start at 11, I just slowly work my way to the middle. The 4 and the 10 would go together. The 5 and the 9 would go together. The 6 and the 8 would go together. And then I'd end up here in the middle at 7. Another option that you could do if you prefer is to average them. So if you do 3 plus 11 and you divide by 2, you'll get the answer. 3 plus 11 is 14. Divide that by 2 and you get 7. And you'll see that this pink point here is right at 7. So the coordinates of our midpoint are 7, 0. I'm going to go ahead and graph number 3 now. So here's point 3, 1, and here's point 11, 4. I'm going to try to find the midpoint again. Now, you might notice that I am using the same numbers from before for the x coordinates 3 and 11. So we already did 3 plus 11 divided by 2. So 14 divided by 2 is 7. What we still need to calculate, though, is the y coordinates. So now I'm going to add the 1 and the 4 together and divide by 2. So 1 plus 4 is 5, and if I divide that by 2, I get 2.5. So my final answer for the midpoint would be 7, 2.5. Okay, now we're going to take some notes. So if you have not gotten the note sheet from the hall supervisor, please pause the video and go do that now. If you're ready, you can just continue on. So the first thing here is midpoint. So we're going to start by filling in the definition of midpoint. Midpoint is the middle point of a line segment, and you get that by calculating the average of the coordinates. So let's do the first example. As I go through these, if you feel like you need to pause the video at all, do that whenever necessary. So here is the start for the x coordinates. So you can see that what I'm doing here is adding my x coordinates 3 and 21 together and then dividing by 2. So 3 plus 21 is going to give us 24. 24 divided by 2 is going to give us 12. So 12 is the x coordinate for our midpoint. Next, I'm going to figure out the y coordinate. So I'm going to use the y coordinates of 10 and negative 4. Add those together still, which gives me 6 divided by 2. And then your answer would be 3. So the way that you are going to write your final answer for the midpoint is 12, 3. Let's look at the next example. So to figure out the x coordinate, I'm just taking the 2 x coordinates I have, negative 7 and negative 18, and adding them together and then dividing by 2. So this time I get negative 25 divided by 2, which is negative 12.5. Decimals are totally fine. You should expect to get decimals pretty often on these. So let's try the y coordinate now. So all I did here was add the 14 and the negative 3 together. I'm going to divide it by 2 as well. So 14 plus negative 3 is 11. And then 11 divided by 2 is 5.5. So here's my answer, negative 12.5, 5.5. Now, if you're not caught up on the notes, this would be a great time for you to pause before we do the next section. The next section is on the definition of bisect. So the word bisect means to divide something into two equal parts. And you can divide either an angle into two equal parts, or you can divide a segment into two equal parts. So we're going to try and fill in the blanks here. So if you look, we've got this big angle here, ABC, and we are going to try to bisect that angle, which means divide it in half. And if you look right down the middle here, BD is what is bisecting that. So we would write that line BD is the bisector of ABC. Here's that same thing, just a little easier to read than my handwriting. Now we're going to try to figure out the the midpoint of the segment. So in this case, our segment is EG, and we're going to try to split it into two equal parts. So to split this one into two equal points, you can probably see that that is at point F. So we are splitting it so that EF is congruent to FG. So here everything is a little cleaner for you. I'm going to rewrite this EF is congruent to FG in case you want to add that to your notes. And then I'll also over here include that angle ABD is congruent to angle DBC. So this angle right here is congruent to that angle right there. Again, if you're not caught up on the notes, go ahead and pause it. Okay, so the next thing that we are going to do is prove whether the triangles are similar to each other. So we did this back a few chapters ago where we worked on similar triangles and we worked on flowcharts. You're going to try some flowcharts here on your own in a moment, but I want to see if I can help you out to try to refresh your memory a little bit. Okay, so you can see the first thing that I did here was to set up a ratio comparing the 16 and the 8 together. So 16 over 8 is 2. Next, I am going to find some congruent angles. So I've got this angle L right here is congruent to angle B. That's just given in the picture, just flat out tells me those numbers. And then the last ratio that I'm going to do is to compare the 6 with the 3. And again, I get a ratio of 2. Since my ratios are the same, these triangles are similar to each other. So in that bottom bubble, you match up all the letters. So we already know that angle L and angle B match up. So I started one triangle with L and one with B. And then I was able to figure out that K is going to match up with A, and then M is going to match up with C. And if you remember your triangle similarity properties, this one is side, angle, side. So now I'm going to have you try some problems on your own, or you can work with some of your classmates if you'd like. You've got this worksheet that has some flowcharts on it, and I would like you to try and see if you can answer those questions, please. After you finish that, you can continue on with the video. So for now, you should pause it, and then when you finish, go ahead and continue on. All right, hopefully you were able to complete those flowcharts. I want to take a minute to go over this flowchart right here and see if you noticed anything about that particular flowchart. So hopefully your flowchart looks something like this, where you do 28 and 28 to give you a ratio of 1, and then you also do 20 and 20 to give you a ratio of 1. And then you've got the vertical angles in the middle that are equal this time. These two triangles are similar to each other by side, angle, side, but I want to know if you can figure out if there's anything else that's special about them. Since these two triangles have a ratio of 1, that means that they're not only similar, but they are also congruent to each other. On Friday, we are going to talk more about congruent triangles, but a key takeaway for today is that congruent triangles have a ratio of 1. Now we're going to look at another set of similar triangles. This picture is on the back of the half sheet that you picked up, and we're going to go through the answers to this. So we're going to start by answering question number 1, which is, are these triangles similar and how do you know? So hopefully you can see there's 2 triangles in this picture. There's this little triangle right here, and then there's also this bigger triangle that overlaps it. So let's talk about whether or not these triangles are similar. So we want to figure out either some angles that are the same or maybe some side lengths that have the same ratio. It looks to me like we have 2 angles that are overlapping in this picture. So these triangles are going to be similar by angle. And if you look at this picture, we've got these 2 overlapping angles. We've got angle KLM in the little triangle that overlaps with angle JLN in the bigger triangle. When they overlap like that and they're in the exact same place, this 63, that's called reflexive property. And we're going to take notes on that in class on Friday. The other set of angles that we know are the same are angle LMK along with angle, along with angle LNJ. Those 2 angles are corresponding angles. Hopefully you notice these parallel lines here. When you've got those parallel lines, you've got corresponding angles that are equal to each other. So these are, in fact, similar to each other. So now we are going to try to answer the next question on your half sheet, which is, what is the ratio between the triangles? So in order to figure out the ratio, we have to look at each triangle separately. So I'm going to go ahead and draw just a small version of each of them. Here's angle KLM. I know this 63-degree angle, I know this 9, and I know this 10. And then I'm going to draw a bigger one here with JLN. So again, I've got this 63-degree angle up at the top. Now, I don't know any of the side lengths kind of on their own, but I can add these 9s together to figure out that this full side over here is 18. So it looks like if I was going to compare these 2 triangles, I would be comparing this 18 with this 9, which means that my ratio is going to be 18 over 9, which equals 2. So knowing that our ratio is equal to 2, we're going to try to answer the last question. Okay, let's try to answer that last question. Sorry if you heard my kid crying. Okay, so we're going to try to figure out how big JN is. So if our ratio is 2, it looks to me like JN is going to match up with KM. So the big triangle is twice as big as the little triangle, which means that JN is going to equal 20. So I just doubled 10 to get 20. This is a new vocab term that we're going to take notes on in a second here. This is called the mid-segment. So grab that blue note sheet and let's fill in your notes. So the mid-segment is a segment that joins the 2 midpoints of a triangle. So on your note sheet, we're going to use that same example we were just working with. K is the midpoint of the side JL and M is the midpoint of the side LN. The mid-segment is the line that connects those midpoints together. You might also see this called the median or the midline. Mid-segment, median, midline, they're all synonyms for each other. So there's a few bullet points for you to fill in about the mid-segment. First is just that vocab term that KM is the mid-segment, which means that K is the midpoint of JL and then M is the midpoint of LN. The next bullet point, I should say, is that the mid-segment is always going to be parallel to the base. So this mid-segment KM is going to be parallel to JN. Because those lines are parallel, we've got corresponding angles that are equal to each other. Then the last bullet point is to know that the mid-segment is half the size of the base. So now we're going to try to fill in the blanks over on the right-hand side. And I'm going to start with that last bullet point that we filled in. So if we know that the mid-segment is half the size of the base, that means that 10 is half the size of the base, making the base 20. Now I'm going to try to figure out C next, and hopefully you remember we just said that we've got corresponding angles that are congruent to each other. In this picture, this 55-degree angle is corresponding with angle C, which means that angle C is 55 degrees. And then we've got two angles left, but you might notice that these are also corresponding angles. So angle A and angle B are corresponding. That means they're going to be the same size. What I would do to calculate these is to look at what we have in the triangle. So we've got this big triangle here where we already have a 63-degree angle and we've got a 55-degree angle. And we need to figure out what else we need to get to 180 degrees. All triangles have 180 degrees. So in this case, those two angles are 62. If you need a moment to pause to finish filling in your notes, go ahead and do that. Otherwise, you can continue watching. The last thing that I would like you to do today is to work on the mid-segment worksheet. So this mid-segment worksheet is on the back side of your flowchart worksheet. I want you to do the best that you can on this. You're going to turn these in tomorrow in class. So go ahead and try to fill in the mid-segment worksheet. And when you finish that, you can work on your homework. Your homework tonight is from Chapter 6, Homework 1, and it's on midpoint and mid-segment. Good luck. I hope to see you in class on Friday. Have a good day.